Good morning. Thank you, honorable mayors, Barnegat Bay municipalities, and guests for attending this, which is our third of 3 information sessions on the development of a nitrogen water quality target for Barnegat Bay, which will be achieved through a pollution budget known as a total maximum daily load, or TMDL as we refer to it. And thank you to the Department of Environmental Protection folks for attending and presenting today. From the TMDL program, we have myself, Kim Seno, we have Helen Pang, our TMDL lead, along with Debbie Kratzer, Crystal Carrillo, and Ryan Hughes. We appreciate Ocean County College for the use of this wonderful facility and for the Barnegat Bay Partnership for the refreshments. Today's session is intended to acquaint you with the TMDL implementation plan component of our TMDL document. In the 2 previous sessions, last November 29th and January 31st, presentations were heard on the background and the science that led to the development of a site-specific nitrogen standard of 450 micrograms as a seasonal average for Barnegat Bay. We also learned that non-point source and stormwater loading reductions would be needed throughout the Bay from all of the 33 municipalities that comprise Barnegat Bay and its watershed. As an update since our last session in January, the United States Geological Survey has prepared a journal article, a 3-dimensional hydrodynamic and water quality models to assess the response to nutrient load reductions in the Barnegat Bay, Little Egg Harbor estuary. This will be for publication in the Bulletin of Marine Pollution. It has been independently reviewed, and the revised article is currently and will be subjected to USGS review approval process, and then it will be submitted to the journal for publication, which we anticipate sometime in the new year. The USGS has undertaken the process to formally archive the TMDL model. They will have the model archive data released publicly available at the time of the journal publication. This will include the Barnegat Bay model itself and all the related files, the input data, the output from each simulation, and the GIS files. It will be available to the public through sciencebase.gov. And a README file will be included in the archive data that provides instructions on how to run the different simulations. The Barnegat Bay TMDL will then be proposed as an amendment to the Ocean County Water Quality Management Plan. This is done through a New Jersey Register publication notice advising that the TMDL is then available for formal public comment. A public meeting date will be published at this time when the department may accept verbal testimony. Written testimony will then be accepted throughout that published comment period. So for today's logistics, please note we are recording the session as we did with our 2 previous sessions, and we will make it available to all registrants and upon request. We will take questions at the end of every presentation. We will start with the attendees that are here in person, and then we will read out loud the questions that we receive in the chat from those of you that are attending virtually. We're scheduled for about a 15-minute break at 10:30. We are very keen to receive your input and hear your thoughts and concerns prior to publication in that New Jersey Register for formal public comment. As I said, we don't have a publication date for that yet. But today's information session is intended to explain how the loading reductions may be achieved to attain site-specific nitrogen target that we had presented previously. Next up, and I'm happy to introduce Crystal Carrillo from our TMDL team, and she will provide an overview of the TMDL implementation plan. And as I said, that is a component in our TMDL document. Thank you.
Good morning, everyone. Can you hear me okay? Great. Good morning, everyone. My name is Crystal Carrillo. I work under Helen Pang on the TMDL team in the Bureau of Environmental Analysis, Restoration, and Standards, or BEARS. I'd like to thank you all for attending. Today, I will be discussing the implementation plan from the TMDL perspective. Okay. So my presentation will cover the nitrogen water quality target and TMDL recap, the MS4 permitting program, Category 1 riparian buffers, funding and watershed-based plans, New Jersey DEP stewardship programs, and New Jersey DEP's ongoing monitoring commitment. So just to recap, during the development of the TMDL, there were studies conducted to establish a relationship between the aquatic life and total nitrogen. Gary Tagon's research on benthic invertebrates was the only study that was able to establish a relationship. Gary Tagon's research established a relationship between the number of sensitive species and the total nitrogen concentration. The relationship can be seen in the highlighted equation that is shown on this slide. You can see that the total nitrogen concentration, as the concentration increases, the proportion of sensitive species decreases. So using this equation, we determined that 450 micrograms per liter would be the ideal target. As Kim mentioned, USGS created a model that helped model the total nitrogen in the bay. The table shows the values in the baseline condition, natural condition, with a 60% reduction in the north and 20% reduction in the south, and the 80% reduction in the north and 20% reduction in the south. Based on the values, we found that the 80-20% reduction was what we needed to meet 450 micrograms per liter, or as shown on the screen, 4.45 milligrams per liter in all 9 of the assessment units in the Barnegat Bay. Okay, so the TMDL implementation plan. The implementation plan is a section of the TMDL where we discuss how the reduction can be achieved. TMDLs are not required by EPA's Clean Water Act. However, New Jersey's Water Quality Management Plan requires an implementation plan to be included in the TMDL. While the TMDL calculates the numeric target to attain the surface water quality standards, the TMDL plan identifies the actions needed to meet the target. A TMDL implementation plan includes the permitting requirements, the current programs and regulations, ongoing restoration efforts, and funded opportunities and monitoring. The Barnegat Bay implementation plan, TMDL, nitrogen target, and load reductions will be implemented through the MS4 stormwater permits and incentive-based programs. The municipal separate sewer systems, or MS4 permits. The Municipal Stormwater Regulation Program has 3 types of MS4 permits: the Tier A, Public Complex, and Highway Agency. The TMDL will be implemented through the Tier A MS4 stormwater permit, which authorizes the discharge of stormwater from small municipal separate storm sewers. In January 2023, the MS4 program updated the Tier A permit to include all municipalities in New Jersey. Before the updated permit in 2023, there were some Tier B municipalities that had less stringent requirements. The updated MS4 permit requires stormwater facility mapping, ordinances, education and outreach, street sweeping every 4 months, and watershed improvement plans. In August 2024, NJDEP issued a draft Highway Agency Stormwater General Permit Renewal. The TMDL can be implemented by the Highway Agency Stormwater General Permit through additional measures. So additional measures and optional measures. The MS4 permits include additional measures and optional measures. Additional measures are non-numeric or numeric effluent limitations that are expressly required to be included in a permittee's stormwater program by a TMDL, a regional stormwater management plan, or other elements of an adopted area-wide water quality management plan. An example of an additional measure would be to establish a schedule to retrofit basins to address water quality. Optional measures are BMPs developed by the permittee that extend beyond the requirements of the MS4 and that prevent or reduce pollution to waters of the state. An example of an optional measure would be planting of native vegetation in existing landscapes. We are interested in any of your suggestions for any optional or additional measure that you would like to see included in the TMDL implementation plan. The additional measures would then be included in the next iteration of the Barnegat Bay Municipality's MS4 permit as a requirement, whereas optional measures would not be a requirement. Green infrastructure and low impact development. Green infrastructure and low impact development can help reduce or prevent nutrient pollution. Green infrastructure refers to stormwater management measures that manage stormwater by treating stormwater runoff through infiltration into subsoil, treating stormwater runoff through filtration by vegetation or soil, or storing stormwater runoff for reuse. Stormwater management rules require MS4 permit holders to employ green infrastructure in all new development. Low impact development aims to reduce and/or prevent adverse runoff impacts through sound site planning in both non-structural and structural techniques that preserve the site's natural hydrologic response to precipitation. Low impact development techniques are those that promote the view of rainwater as a resource to be preserved and protected. Examples of green infrastructure and low impact development would be rain gardens, conservation landscaping, water harvesting using rain barrels and cisterns, or green and blue roofs. Category 1 waters. Category 1 waters are protected from any measurable changes in water quality because of their exceptional ecological significance, exceptional recreational significance, exceptional water supply significance, or exceptional fisheries resource. The Flood Hazard Area Control Act rules require that the width of the riparian zone along C1 waters and all upstream tributaries in the same HUC-14 be 300 feet. Riparian zones are the vegetative buffer between development and water conduits. Vegetation along riparian zones can absorb tremendous amount of storm water runoff. Category 1 streams are among the most sensitive and have the largest buffer areas. The map shows the C1 waters in Barnegat Bay, in the Barnegat Bay watershed. There are currently about 1,200 miles of C1 waters in the Barnegat Bay watershed. Funding opportunities. So in the following presentations, there will be representatives from the first two programs listed, the New Jersey Water Bank Program and the NJDEP's Water Quality Restoration Grants to mitigate non-point source. The New Jersey Water Bank Program provides low-interest loans for the construction of water quality protection and human health measures, including stormwater and non-point source management facilities. New Jersey DEP's water quality restoration grants to mitigate non-point source can be used to implement TMDLs and 9-element watershed-based plans. The NJ Clean Communities grants can be used to address litter abatement. Green Acres local assistance grants and loans are for open space acquisition for recreation and conservation. The Shore Protection Program is to protect public and private property from coastal storm damage. The Supplemental Environmental Project, SEP, is an environmentally beneficial project that may be voluntarily incorporated into a NJDEP settlement or enforcement matter to reduce costs of the penalty. And Flood Mitigation Assistance Grant is the FEMA Federal Funds Reduce risk of flood damage for insured structures and buildings. These funding opportunities are an identified means to fund projects that will mitigate stormwater loads that carry nutrients to Barnegat Bay. $319 grants. Over the past 20 years, the DEP has funded 44 non-point source restoration projects and plans through grants for over $19 million. The tables show the breakdown of projects by location and by project type. Projects have been completed throughout the Barnegat Bay, covering the north and southern part of the bay. Varying types of projects have been funded, and the pictures that are shown here are from the Metedeconk Watershed Plan implementation plan completed by Brick MUA. There's a rain garden in that top corner, and then I know the focus for these pictures was Lake Shenandoah and Brick Plaza. So that picture below shows a little display from the Brick Plaza location, and then the rain garden and another picture. All right, so the examples of NJDEP grant funded and local funded projects. So non-point education for municipal officials, or NEMO. NJDEP partnered with Save Barnegat Bay to educate the municipalities and local communities about stormwater and its impact on Barnegat Bay. Save Barnegat Bay has numerous resources on its webpage for municipalities on basic stormwater education, trainings, and to acquire stormwater points for MS4 permits. This is an example of a project completed by Brick Township MUA. This is the Moses Milch Drive Detention Basin retrofit. Brick MUA has a watershed-based plan, which they previously presented on, and Moses Milch Drive Detention Basin retrofit is an example of one of the projects in their plan that has already been implemented and that mitigates nutrient loads. The stormwater basin structure is used to hold water and treat stormwater runoff. Stormwater basins help reduce flooding and keeps runoff from entering directly into the waterways. Barnegat Bay Partnership has also been active in implementing stormwater best management practices to reduce nutrient loading. So listed here are a few of the 9-element watershed-based plans in Barnegat Bay: the Metedeconk Watershed Plan by Brick MUA, the Twilight Lake Protection and Watershed Management Plan through the Borough of Bayhead, the Watershed Restoration Plan for Little Egg Harbor tributaries completed by Rutgers University, the Toms River Watershed Plan, and the Oyster, Cedar Creek, and Forked River Watershed Plan completed by Barnegat Bay Partnership. The plans identify specific best management practices to achieve non-point source reductions. They include the location for the project and the estimated cost. The projects identified in the plan are eligible for 319H funding, and they follow EPA guidance and are approved by NJDEP. And later this morning, we will hear from Barnegat Bay Partnership on their forthcoming watershed-based plans and identified projects. Stewardship. So we'll look at stewardship in Barnegat Bay through the AmeriCorps program, the New Jersey Community Water Monitoring Program, and the Barnegat Bay Blitz. The goals of the New Jersey NJDEP's AmeriCorps NJ Watershed Ambassadors are to promote watershed stewardship through education and direct community involvement, and to monitor stream health through performing visual and biological assessments. The AmeriCorps NJ Watershed Ambassadors are a resource to all communities in New Jersey. They are available to make presentations to all age groups on non-point source and watershed management and can provide assistance in meeting MS4 permit education and outreach obligations. In 2019, an ambassador installed ship gardens at Jake's Branch Park. And then in 2021, another ambassador helped with the maintenance of the gardens. The gardens are estimated to have helped with 8,200 gallons of water. There have also been rain barrels created, about 45 in the last 5 years, and they have helped prevent 63,000 gallons of water from entering the water body. The link to more AmeriCorps information is provided below. NJDEP's Community Water Monitoring Program. Community water monitoring is a collection of scientific water quality data by concerned citizens working in partnership with professional scientists and government decision makers. This valuable data helps determine the ecological condition of local water bodies, as well as identify the causes and sources of water quality impairment. The objectives for community water monitoring are to increase the quality, quantity, and spatial extent of data produced by community water monitoring programs to aid in assessment of state water quality conditions and to support science-based decisions. Current community water monitoring programs in Barnegat Bay watershed are run through Clean Ocean Action and Barnegat Bay Partnership. NJDEP and the New Jersey Watershed Watch Network, funded through a grant to the Watershed Institute, provides technical assistance in QOPs and data management, templates and guidance, clearly defined pathway for data use and acceptance, training and workshops, listing on participant map, and information sharing between the community water monitoring organizations. The Barnegat Bay Blitz. The Barnegat Bay Blitz was initially started by NJDEP in 2011. It is now currently led by the Barnegat Bay Partnership, and it is an annual watershed-wide cleanup that brings together hundreds of volunteers for clean water. For more detailed information and to help participate, I will include a link. Or you could visit Barnegat Bay Partnership's website. So New Jersey NJDEP's long-term monitoring commitment. Phase 1 began in 2013 and went until 2018. Phase 1 of the Barnegat Bay Long-Term Ambient Monitoring Program collected data for 5 years. Then that was in 2013, and then phase 2 started in 2018 after the department released the Barnegat Bay Restoration Enhancement and Protection Strategy. A revised QOP was signed in 2018 to cover the phase 2 Barnegat Bay long-term ambient monitoring programs from 2018 to 2023. The monitoring stations and buoys are shown in the map, and the data was collected from both in-bay stations and tributary stations. So if you look at the map, the in-bay stations are, oh, you can't see it. If you look at the map, the in-bay stations are plus signs with a little black dot behind it. The tributary stations are dots, so you can see they're in the tributaries along the watershed. And the in-bay stations are in the bay. Okay, so in July of 2023, phase 3 started, and it will continue until June of 2028. It includes continuous monitoring at 4 buoys and 1 fixed station. The data will be collected every 15 minutes, and the parameters collected include DO, pH, temperature, turbidity, conductivity, salinity, and chlorophyll A. Discrete monitoring will be collected at 20 in-bay stations and 18 tributary stations. It will be collected once a month with at least 2 weeks in between collections. The parameters monitored are pH, water temperature, DO, and specific conductance. The map shows the locations of the stations and buoys for phase 3. The stations have changed a little, or may have changed a little, in between each of the phases. The data can be found on the water quality portal, and the department's commitment to monitoring in Barnegat Bay provides a complete picture of real-time conditions in the bay and water quality trends. NJDEP will prepare a summary data report for inclusion in an appendix to the TMDL report. Thank you.
Any questions? We have a mic. I'll run around with it. If anybody has any questions for Crystal?
Hi, thank you for the presentation. Just a quick question on the community monitoring program. So that's volunteers who are doing the data collection, right?
Yes.
Are those folks trained in QA before they do the data collection?
Yes.
And the data is QA'd and you guys are actually using it to make decisions?
Yes.
Okay, great. Thanks.
In the last slide that dealt with the monitoring program, did I miss? I don't see nitrogen in that list.
Yeah, good catch. I think those parameters for that bullet, that means the in situ parameters. So we do send all the sample to the lab to do all the nutrient series analysis. Yes, we have a suite of parameters being analyzed. Thank you.
So I've been looking at the Chesapeake Bay Total Maximum Daily Load Action Plan. And of course, it's much more complicated because it involves many states, many counties, and many municipalities. By comparison, we're talking about one county and either 33 all municipalities, which the action plan has reduced it to about 17 or 18 municipalities with the most serious problem. You folks deserve great credit for the monitoring program, which has really identified the action areas where the most impairment occurs, and the changes that have been made to the stormwater rules, which implement many of additional measures that could be implemented. My question really has to do with what is the next step in terms of integrating both and identifying the areas of most concern with the greatest impact of nitrogen problems, for example, Toms River, and identifying the projects that would really reduce nitrogen loading in the Toms River and prioritizing those projects based on either the volume of stormwater that takes place or some other measuring point, such as the amount of impervious cover and the greatest nitrogen concentrations. So a list of what's the plan to get to a list of priority projects in the areas with the most nitrogen impairment, and then measuring the result of the project. I see you've put up a lot of data of projects that have taken place that DEP has funded, but it would be nice to find out how much nitrogen reduction has taken place as a result of those projects. And I'd like to see that the plan includes those kind of activities and those kind of results.
There's a lot in your. Your point about, the existing projects, some of which we highlighted a few examples. If it is funded with federal $319, we do report out through a grant report tracking system to EPA on that particular BMP's nitrogen, TSS, and total phosphorus loading reduction. So we certainly can pull that together based on that 44 project list, the ones that were specific BMPs. We can certainly put that together and say work in the past 20 years in the watershed has addressed nitrogen and give the loading reduction. So we can do that. As far as your suggestion moving forward, prioritizing projects for implementation, we look to the 9-element watershed-based plans to do that. And we look then, as we're transferring this document upon adoption to the municipalities for inclusion in the MS4 permit, we look for the municipalities to then start to prioritize based on the wonderful work that the locals are doing and that the department has helped fund. So while we may not prioritize projects per se in the TMDL document, we will lay out what we think the locals could and should do with the resources available to them, the projects underway. Stan, I think, wants to add to that response.
Yes, I would. Thank you. Charles, that is a great question. And monitoring is very important because it helps us assess how we're doing. And this monitoring program has been going on since, 2013. Data in other systems indicates that if you turned off all of the nutrient loading to the bay right now, you likely wouldn't detect a difference for at least 5 to 10 years. So there's a considerable lag. And, that's one of the importance. It illustrates the importance of all these land use elements and rain barrels and swales and all of these other things, because we're trying to get more water into the ground. That slows down the delivery and the processing of those nutrients. So more are captured in place and become sort of a natural element in element cycling, water cycle, nitrogen cycle, phosphorus cycle, et cetera. So it's a really challenging issue. And I don't want to say you want to accept it on faith that it's working. We'd like to see some response, but this is a long-term plan, and we have to be in it for the long term.
Going back to how much is too much, this is late in the game, but I'm sure you have an answer. It appears to me, if I understood it correctly, we based this standard that we're aiming for on one study that dealt with sensitive species of little organisms. Has anybody given any consideration to are there any benefits to nitrogen? I know there are problems with eutrophication in particularly freshwater lakes and ponds. I've been there. I've seen what the agricultural runoff does. But if we're interested in, submerged vegetation, and we're interested in salt marsh grasses growing, does the nitrogen benefit that?
Thank you, Helen.
So, as I explained at the second stakeholder meeting, so it was a procedure for us to identify the site-specific target. So we did check different components in the aquatic system. This is the only one gave us the promising result, which allow us to make the connection between the water quality and then benthic macroinvertebrate. So this is the information we base for this phase. I believe, we will be able to further evaluate and then maybe get more information But regarding the nitrogen concentration, I think this is an interesting question with regarding to the SAV. We have to be very careful. I think Stan probably there, we know we had that discussion, like how much nutrient is the good level for this part of the problem. And then we also need to consider another side of the problem. We need to keep an ideal balance there. I don't know, Stan, you want to add some? Okay.
I think what I would also add on that topic was on the side, we did take additional data to look at what would happen with, what might be driving some of the sensitive species. So when I took a deeper dive into the data and you started looking at, say, chlorophyll, which would be an indicator of algal blooms in the water that could shade, cause other problems that would impact seagrasses. What you find is you come pretty close to about that same 450 level for any threshold that was set for chlorophyll, as an indicator by, say, 5 micrograms per liter by EPA in their programs. You get right around that same 450, from a chlorophyll perspective. And then when you looked at some of the other parameters that you looked, I believe I looked at oxygen too, and that's around the same level. You started seeing that oxygen deplete. So I think there's an overlap of why we might be seeing this impact. So this was a great indicator because it encompasses a lot of different, factors that would drive the biology from being healthy or not.
You all, through the modeling, you didn't see any tremendous increase in SAV when you cut the nitrogen load even lower.
No.
So to your point, that higher nutrient load is used by the SAV, but it does influence those other things negatively, if there's more out there.
Yeah, just speaking to the SAV, there's a spectrum. So as the nutrient load increases, you're going to start losing the SAV to macroalgae. And then as the nutrients increase further, you lose it to regular, planktonic algae. And so, there's other systems to look to on the Atlantic coast that are at different levels of loading comparatively to us. And you see a pretty consistent spectrum relationship. As those nutrients decrease, the SAV is able to outcompete the macroalgae. But as that nutrient load increases, it loses the battle.
Simply put, correct me if I'm wrong, nitrogen in the water column is not as easily available to the SAVs that need nutrient loading in the soil for them to grow properly. Is that correct?
Correct.
Okay, so I think that answers that question most simply, I think.
Any other questions? All right, we have no online questions. So I think if nobody else has any questions, we are good to move on.
Thank
Awesome.
you.
Thank you.
Good morning. Thank you. My name's Paul Hauk. I'm with New Jersey DEP Municipal Finance and Construction Element. And I've been with the DEP for 37 years. The first 28 years I was working for the water bank doing construction monitoring. In the last 9 years,
Okay, thank you. We're going to